This video is going to help you understand how graphs can represent the motion of an object. It's kind of assumed that you've already done an in-class activity where you use motion detectors and computers to generate graphs by walking. If you haven't done this yet, make sure you do this first before viewing this video because there's understanding that you need to gain from the activity to really understand what's happening here with these graphs. We're using this as kind of a wrap-up and a summary of what you needed to know from that activity. So to start, we want to understand something called slope. Oops, I need to select a pen. Slope in IB physics is often referred to as the gradient. Those two terms are interchangeable. So hopefully remember from math that slope is equal to the rise over the run, but more importantly is equal to the change in y over the change in x. What that implies is it shows how one variable's change is influencing the other. So in the case of a distance versus time graph, we find out how the change in distance is influenced by the change in time. The more time that goes by, the faster or the bigger or smaller this number becomes, shows what direction we're moving and what the speed is. And if you kind of remember from an earlier video, change in distance over change in time essentially gives us speed or velocity. So that's one of the main important things we need to kind of take from this set of graphs you're going to see is that the velocity is represented by the slope. Notice that these two things are really pretty much the same type of formula. So we're going to start off with an x and y axis on the left side and a description here in the middle. And what we're going to need you, or hopefully be able to do, is understand what's happening. So at first we have an object at rest. So if I kind of take an object at rest, it could be right there on the x-axis because again, if the velocity is equal to the slope, and in this case, my velocity, in this case, my velocity is equal to 0, that means I should not have any slope. And this line could occur in a number of different spots. It could occur on the x-axis. It could occur right here. It could even, that's not sloped. It has a slope, I should say. It could occur here. It could even occur down here. All three of those indicate no motion because we're not changing our position on the y-axis. Relatively simple example, a good one to start off with. The next one is motion at a constant positive speed. So what that basically tells us that is our velocity, still on that line tool, but our velocity or our slope is constant. And that kind of goes from what we were talking about before. So that means I have to have a line that goes positive slope moving up and to the right, but be relatively straight. So there would be positive constant speed. Another way I can kind of tell this is, okay, I go 1 second and I check my distance. So let's just say this is 1 second and that's 2 meters. And then if I go to 2 seconds, if I go up here and kind of check, I should be at 4 meters. If I go to 3 seconds, you might probably notice that I'm at 6 meters. And we notice that this is this is constantly increasing its distance at the same rate. So if we take that idea now and go down here where our velocity is equal to our slope and it has to be a constant slope, well now the only thing that's different is this is a negative slope, which means it moves from left to right but goes downward. So this would be a constant negative speed. Again, straight lines, which I guess that's probably an important thing to make a note of. Straight lines equal constant speed or constant velocity. In this case it's negative, so it's going down and to the right. This was positive, so it's going up and to the right. If our speed is increasing, well now this increasing means I have an increasing slope. Remember, slope was equal to velocity. So now I have to have something that's becoming more steep as I move from 0 seconds onto whatever time I have. So to increase my steepness, I know this is going to start to go up and curve in an upward direction. Here it's not as sloped as what it is up in this area. Down here, I have an increasing negative speed. So again, negative speed, we hopefully remember, is going to move something along that line. But this has to have an increasing slope to it. So it has to become more steep. So in this case, it's going to go something like this, where you can see that the bottom here is becoming more steep than what it was here on top. It's almost like if something's going down a very steep hill, and the speed is going to continue to increase as it gets towards the bottom. So again, as long as you remember slope equals speed, and you know that positive speed goes up and to the right, and negative speed will go down and to the left, or down and to the right, what happens with that slope becomes a little easier to understand. The last thing is if we have a decreasing positive speed. So now this decreasing basically tells us we're going to lose slope because we're losing velocity. But we're still going in a positive direction, which means we have to go up and to the right. So in this case, we're going to start going up, but we're going to level off and eventually work to this flat line that we talked about in the first graph that we looked at, where we had 0 slope. So starting off at speed and gradually getting to a point where we're not changing positions on the y-axis anymore. Decreasing negative speed also means we're going to lose slope. But this time we have to do it going this direction because, again, we're going in a negative direction. So I might start in this way and slowly make my way down and level off. Again, started with slope, ended with very little slope or no slope at all. And one of the other things we want to take note of, it doesn't matter in a distance versus time graph where these graphs start. This could have been below the x-axis down here. This could have been below the x-axis here and done the same thing and given us the same information. So that's our distance versus time graphs, and the main ones that we need to be aware of when you're dealing with motion and graphing.